Hello, my name is Nate Denton, and this is Project 2.3, 555 Timer Unpacked. So, this is the 555 timer proper, and this is the 555 timer unpacked. From about here to about here is what is actually inside of this tiny little chip, which I will show in a second. In the 555 timer, we have an astable mode created by R1, R2, and C. R1 and R2 and this potentiometer are all connected in series, connecting to pins 2 and 3 on the 555. The potentiometer changes the frequency of the impulses, so we can go from really slow to really fast. Here is how it works in a simple drawing. You can imagine in this as water. We have a dam as the capacitor, and as 5 volts of water fills up, it hits the trigger when comparison to 3 volts also supplied by 5 volts. We have 2/3, 1/3. When 1/3 voltage is activated, and here is the truth table for the NOR chip. Based on this truth table, we get the output but that's not important for now. The water current keeps rising, and eventually we get the threshold. Threshold activates this line, and which activates the 3904 transistor. This lets the water siphon out through this 100K resistor and goes into ground. That is the basics of how it is astable, as the current just fills and the same process repeats itself. Down here we have a NOT that inverts the signal to the LED before it goes to ground. And here we have our op amps, which are the comparators, and here we have the SR NOR latch, which is how the signal is held, which also lets it be monostable, which I have an example for, or breadboard prototype. Here is that breadboard prototype. So over here we have the buzzer project and a real life example, which is based off a doorbell, except instead of another buzzer, I have an LED. So the buzzer, which you will hear now, is quite painful. So I will take it out when I demonstrate the feature. But the basic idea is I have 2 series resistors here, which act to increase the amount of resistance as R2. So both these resistors are R2. That sum is 6.9 kilo ohms of resistance. And together, that equals about 2 kilohertz, which is the operating range for this piezo. Over here, we have a real-life example of what this might be. In my case, is a doorbell. So when I click ring, I'm here, it lights up, buzzes, says somebody's at the doorbell. We have a little debouncing mechanism using a 103 ceramic capacitor. Otherwise, it is pretty similar to all the others, except it is monostable just based on the setup. Here are the calculations. So for the astable, we have the time high for the top square for when square wave is 1 or on, time low for when the square wave is 0, and the frequency. This is basically how we know what the frequency is of the total period of time in hertz. For monostable, there is one equation, and it is this. Thank you, and hope you had a good time watching this.